So our lesson is on transformations of functions. Our learning goals are learning to apply transformations of functions to the parent functions, okay? And using technology to facilitate an understanding of transformations. We're going to look at stuff on Desmos. And we're just going to focus in this first lesson on the square root function and the absolute value function because they're pretty easy functions to learn the transformations from. Okay, so sketch the parent function y equals absolute value of x. So here we are. So that's the parent function. So what you want to do is have them memorize that we're doing this in 2 days instead of like a week, but we're going to draw them a bunch of times in that week. So square root function has a starting point, 0, 0, and it's a half parabola on its side. So it has that step pattern over 1 up 1, over 3 up 1, over 1, 2, 3, 4, 5 up 1. So when you see square root, you're thinking the parent function is this. And then image functions that go with the parent, they've got to have the same general shape of the parent. Okay? So you can't have an image function of a square root function looking like a absolute value. Okay? So if the parent is a square root, then all the images will be square roots as well. Okay? So we're starting off with sketching our first image. I'll use red for it. It's going to be y equals the square root of x minus 2. Anyone have an idea of what they think that would look like? Yes?
It would be the same curve that just starts to lower.
Yes, you are correct. The same curve, but starts 2 lower. So to have the exact same shape, but start 2 lower, I start 2 lower, but I'm still going to go over 1 up 1. Over 1, 2, 3 up 1. Over 1, 2, 3, 4, 5 up 1. Okay, so they're congruent. If I cut the red one out, I could put it on top of the black one and they would fit exactly on top of each other. Does everyone see that? Doesn't affect the shape at all. Okay, it just affects where it starts. And compared to the original, it starts 2 squares lower. So we call that a vertical shift because it shifted vertically up and down. Okay, a vertical shift. So that's the overall transformation. And then you put a little semicolon and then you give the exact details of that vertical shift. So that vertical shift was down 2. Okay? So it was a vertical shift down 2. So based on that, does anyone have an idea of what y equals the square root of x minus 5 is going to look like?
You're going to go down 5.
Yep. So it's going to start at -5 on the y-axis. But it's going to have exact same shape again. So over 1 up 1, over 3 up 1, over 1, 2, 3, 4, 5 up 1. And that transformation again, this one's going to be called a vertical shift again. But this time, it's specifically, after the semicolon, down 5. And then y equals the square root of x plus 3. It's going to start 3 up from 0. Still have the exact same shape. And that one's a vertical shift of 3. And y equals the square root of x plus 6. It's going to start at 6 on the y-axis. Exact same shape. And it's a vertical shift up 6. And there are vertical shifts. Okay? Pretty easy to see with the square root function. Just start up or down, and move up or down from 0. So given a function y equals f of x, so that means it could be the square root function, the absolute value function, the parabola, any of the parent functions. So given any parent function, how would you describe the transformation where you take that parent function and add k? It would be a vertical shift, right? So whatever this function is, if it's got plus a number, vertical shift, and it's going to be either up or down depending on whether it's positive or negative. So I'm going to write them like this. If it's positive, you're going up. If it's negative, you're going down. K units. Okay? It's going to be a vertical shift, either up or down, K units. Does that make sense, everybody? Vertical shifts? Okay. Sketch the parent function y equals square root of x. Same parent function again. And then we're going to sketch each image function and describe the transformation in words. So you guys should all be able to draw the parent. This is y equals square root of x. Just the plain one. So starting at 0, 0, over 1 up 1 over 3. That's the parent. So I'm going to use black to draw my parent function. So here's my parent way down here. So it starts at 0, 0, over 1 up 1, over 3 up 1, over 5 up 1. And I'm just going to underline it. I did. So that's my parent. Everybody got on the parent? Okay, so the first image we want to draw is y equals 2 times the square root of x. The 2 up front means multiply. Any ideas what it would look like? Okay, we'll go to Desmos and look and see what it looks like. I'll put them both on. Okay, so here's the parent. And here is the image. So, do you see that it's a lot steeper, if you want to call it that? Okay, so they start in the same spot, but I'm going to switch the scale here. So normally we'd be at 1, 1 here. You see that because of the scale, that's the 0.11 where my finger is. So instead of being at 1, 1, I'm at 1, 2. I've doubled the y value. And then normally I'd be at, so I'd go over 3, which would make me at 5, which is here. No, I'd be at 4, sorry. I'd be at 4, 2. Instead of being at 4, 2, I'm at 4, 4. I've doubled the y value. Okay, so I'm doubling the ups, in other words. Okay, so I'll show you how that works here. I won't leave it, I'll just minimize it. So I'm doubling the ups, but I'm keeping the overs the same. So I start here, I go over 1, and instead of going up 1, I go up 2. I go over 3, and see all my ups were 1, instead of going up 1, I go up 2. I go over 1, 2, 3, 4, 5, instead of going up 1, I go up 2. So I've doubled all my ups, okay? So if that's called in transformation language is a vertical stretch, because I'm stretching it vertically. My ups are being doubled, okay? So when you write that out using transformation language, it's called a vertical stretch. That's the overall transformation, and then you want to say specifically what it is. So instead of saying multiplied by 2, we say by a factor of 2. So, and then I'm just going to put in brackets here, ups are twice as big as the parent. Okay, so that's what vertical stretch by a factor of 2 means. Your ups are twice as big as what they are in the parent function. Okay? Doubling them. Okay, because of that, does anyone have a theory on what y equals 3 times the square root of x would look like? Yep. You triple the ups. Okay, so instead of going up by 1 each time, you're going to go up by 3 each time you go up. So we're still going to start at 0, 0. And instead of going over 1 up 1, we're going to go over 1 up 3. And then normally we'd go over 3 up 1, so we're going to go over 3 up 3. And then normally we go over 5 up 1, so we're going to go over 5 up 3. Okay, so that's stretched even more compared to the parent. Okay, so that's going to be a vertical stretch by a factor of 3. Okay, so we'll write that out here, a vertical stretch by a factor of 3. All right, anyone have a theory on what y equals a half times the square root of x would look like? Yep, so my ups are half as high. I go up a half each time. So I'm still going to start at 0, 0. But instead of going over 1 up 1, I'm going to go over 1 up a half. Okay? And then I'm going to go over 3 and up a half. So I'm right on a corner this time. So I'm halfway here, then over 3 up a half, then over 1, 2, 3, 4, 5 up a half. So I'm halving the ups. I'm cutting the ups in half. Okay? So we don't call that a vertical stretch because it's not stretching it up at all. We instead call it a vertical compression because compared to the parent, we're compressing it. Okay? So this is called a vertical compression. And whenever you use the word compression, you're going to use like a fraction. So vertical compression by a factor of a half because we're halving the ups. And you can see the relationship in your words. So by a factor of a half, look what's out front, a half. By a factor of 3, look what's out front, a 3. By a factor of 2, look what's out front, a 2. Okay? Just make sure you know the difference between when to use the word stretch, you're making them bigger, and when to use the word compression. Okay? right? What about y equals negative square root of x? Any theories? Yeah. Over 1 down 1. Very good. So you need a different color for that one. So we're still going to start at 0, 0. And we're going to go over 1 down 1, over 3 down 1, over 1, 2, 3, 4, 5 down 1. So this one was my parent. Do you see if I were to fold the black one along the x-axis, it would line up on the purple one? If I were to fold this piece of paper over the x-axis, black and purple would line up on top of each other. Okay, that's called a reflection. And because it's happening vertically, like we're going from going up to going downward, it's called a vertical reflection. So we don't say structure compression, we just say vertical reflection. Vertical reflection. Okay, that's all you need to say there. You don't need to say by a factor of -1. Reflection means opposite of the appearance. Okay, what do you think about y equals -2 root of x? A reflection, and you're going to double the downs. Okay, very good. Very good. Okay, so we're going to start here. And instead of going over 1 down 1, we're going to go over 1 down 2. And instead of going over 3 down 1, we're going to go over 3 down 2. Down 1. And then over 5 down 2. So this one is important because there's 2 transformations happening. The negative sign is a vertical reflection. So if I just want to talk about the negative sign, we have a vertical reflection. That's our first transformation. And then the 2 is a separate transformation. That's a vertical stretch. By a factor of 2. Okay, and you never say by a factor of -2. All right, the vertical reflection takes care of the negative sign. And then the stretch by a factor of 2 takes care of the 2. They're 2 separate transformations. Okay? So a common mistake is people say vertical stretch by a factor of -2. Don't do that. Remember, the negative is one transformation, the reflection, and the 2 is the stretch. Okay? Great, great. So given a function y equals f of x, how would you describe the transformation y equals a? So a number up front multiplying by f of x. What does that number out front do? What's it? Sorry? Yes. Okay, so if a is greater than 1, okay, we just learned that notation. If a is greater than 1, there's a vertical stretch. Now look what I'm writing here. You guys tell me what that means there.
0 and 1 like a fraction. or-
Yes. Any number between 0 and 1. So think of the numbers between 0 and 1. 1/2, 1/4, 2/3. Okay, 1/5. Any number between 0 and 1 is a fraction. Okay, so that's going to be, there's going to be a vertical compression. And then a little note, if there is a negative sign in front of A, there is a vertical reflection. Okay, so if A is greater than 1, like 2 or 3 or 4, there's a vertical stretch. If it's between 0 and 1, there's a vertical compression. And if there's a negative sign in front of A, there's also a vertical reflection. Okay? So A can tell you quite a bit about it as well. So now we know A and K. So we're going to try this. Sketch the graph of the parent function y equals root x. Everybody should be able to do that. Uh-oh, look what I did here. Change this. Change my mouse so value to square root. My God. Okay, so we'll draw our parent function first. Now, some people can look at this image and draw it. Okay, and if that's you, that's super great. You can do it. But I always like to do C before B. I always like to list off my transformations and then draw my graph based on my words. That's how I like to do it. So I like to look at that negative sign and say that there's a vertical reflection. So I know that when I draw it, instead of going upwards for my image, I'm going to be going downwards for my image. Okay? So I've taken care of that negative sign there. Then I look at the 2 and I say, okay, I know there's going to be a vertical stretch by a factor of 2. Okay. And then what does this plus 3 do at the end?
That tells you where you're actually going to start.
Yes. So that, and what did we call that? Do you remember? In the first page? It's called a vertical shift. Okay? I like how you said it tells us where we're going to start. Vertical shift, and it's up 3, because it's plus 3. Is everybody good? Okay, so as Darius said, that shift, we're shifting the starting point. I always like to think of that, especially with the spirit function, as we're going to shift that starting point. If I've got any shifts listed here, I'm always going to shift the starting point. Okay? So I'm always going to look and see if I've got shifts. Is everyone good with that? So I do have a shift, and my shift is up 3, so my starting point is going to be shifted up 3. But then I'm going to follow the other instructions I have up here. I want a vertical reflection, so instead of going upward, I'm going to go downward. Does everyone see that? And I'm stretching my downs by 2. So instead of going down 1 each time, following the parent, which goes up 1 each time, I'm going to go down 2 each time. Okay, so I'm going to go over 1, down 2. Over 1, 2, 3, down 2. over 1, 2, 3, 4, 5 down 2. And then I'm just going to draw in my graph. So that is my picture of y equals -2 square root of x plus 3. Okay? And then, so I've already done C, I described all the transformations in words, I just sketched the image. Now I want to state the domain and range of the image. So look at that green picture we just drew. And see if you can figure out the domain and range. Anyone think they know the domain? The green one? Yep, Doc.
Every real number as long as x is greater than or equal to 0.
Good. Okay, so coming across, not till here, and then everywhere after. How about the range? Eva?
Every real number unless for one to be less than
Very good. Less than or equal to 3. So we're always on the graph, always on the graph, always on the graph up to 3. Then we're not on the graph after that. So less than or equal to, below that. Okay? All right, awesome. It's break time. I'll pause this. Okay, one other thing that I always like to do is after I've drawn in my image, I like to look back at my words and make sure that it fits. So is it vertically reflected? Yes. Is it vertically stretched compared to the parent by a factor of 2? Yes. Okay. And is it shifted up 3 from the original? Yes. Okay, so I'd like to make sure the words match the picture. Okay? All right. Next question. Sketch the parent function y equals absolute value of x. So we've got a new parent to draw. So that's our V shape. Okay? So we're going to draw that parent. So it's got the vertex here. And then it's just the V over 1 up 1 in both directions. And use a ruler when you're drawing the absolute value function. And make sure you put arrows on the ends of your graph there. And then I'm going to use a legend, so I'm going to do the image function in black. You guys did it in pencil, perhaps. Okay, and then part B says to sketch the image function y equals 1/2 absolute value of x minus 3. But before I do that, I want to list out what the transformations are. So I'm going to do C first. So this half out front, does anyone know what that's going to be called? Good. Vertical compression. You have to say by a factor of, but yes, vertical compression by a factor of 1/2. So instead of my ups being 1, my ups are only going to be 1/2, because I'm halving my ups. Okay? And then what about this minus 3?
That's your vertical.
Yes.
You're gonna go down.
Very good. So that's my vertical shift. And because it's negative, it's down 3. So I look for shifts first of my words, and I look for things to shift. Like I like to shift my vertex and my starting point, if I can. If I have one of those, I always want to shift those first. So I do have a vertex here, so I'm going to shift my vertex down 3. Okay. So there's my new starting point. Now, instead of going over 1 up 1, because I have a vertical compression by a factor of a half, all my ups are going to be half. So I'm going to go over 1 up a half each time. So over 1 up a half on both sides. And then over 1 up a half again on both sides. And then over 1 up a half again on both sides. Okay, and then draw that in with a ruler. Arrows on the ends. And then make sure that your words agree with your picture. So do we have it, is it compressed vertically, squished down this way? Yes. Okay, by half. And is it shifted down 3? Yes. Okay. And then D is usually domain and range. So can you figure out the domain and range of the image? So what did we get for domain? All real numbers? Yes? Okay. And what about range? All the way down here, not on the graph until -3, yep.
Any real number that is greater than 4 equal to -3.
Good. Yeah. Okay. All right. Excellent. All right. Sketch the parent function y equals square root of x. We've got that one nice and memorized. So it starts at 0, 0, over 1 up 1, over 3 up 1, over 5 up 1. So that's my parent function. Anyone think they know what y equals the square root of x minus 4, where the minus 4 is under the square root sign with the x? What's it going to look like?
Start,
A -4? Okay, that's a good guess. Let's look. So square root of x, and we want square root of x minus 4. No, start 4 to the right. Okay. I would say to myself, x's are opposite of what you think they're going to be. Okay. Y's are the same as what they look like. X's are the opposite of what you think they're going to be. Okay. So we actually move 4 to the right. So, let's do this in red. So we start 4 to the right, 1, 2, 3, 4. We still go over 1 up 1, over 1, 2, 3, up 1. We go over 5 up 1, but we run out of room. Okay, so it's got the same shape. The overs and ups are exactly the same. It just starts in a different space. This one's called a horizontal shift. Just a shift. Shifts don't change its shape. And then you say specifically in this case, it's right for. Okay. Horizontal shift, right for. Okay, based on that, what do you think about y equals the square root of x minus 1, where the minus 1 is under the square root with the x?
You go one to
Go 1 to the right, it's going to start 1 to the right, good. And then you're still going to go over 1 up 1, over 1, 2, 3 up 1, over 1, 2, 3, 4, 5 up 1. So that's a horizontal shift. Right. 1. How about y equals the square root of x plus 3 with the plus 3 is under the square root sign? Three to the left, very good. Okay, so it's going to start 3 to the left. Same shape. Okay, so that's a horizontal shift. Left 3. And y equals the square root of x plus 7, where the plus 7 is under the square root sign?
7 to 5.
Yes. I think I can fit the 7 maybe this time. 1, 2, 3, 4, 5, 6, 7, yeah. Oops. So that's a horizontal shift. Left 7. Okay. Given a function y equals f at x, how would you describe the transformation y equals f at x minus h? So you're replacing x, look here, you're replacing x with x minus a number. X minus a number. You can think of x plus 3 as x minus negative 3. Okay, so you're replacing x with x minus a number. What does that do to the original? Shifts it left or right. Okay, so it shifts it horizontally to the left or the right. And then just for reference, if it looks like x minus 8, sorry, plus h, it would be to the left, and if it looks like x minus h, it's to the right. Okay? It's kind of opposite what you would intuitively think. Okay? If you see plus, then it's to the left. If you see minus, it's to the right. Okay? Alright, so sketch the parent function y equals square root of x. Sketch each image function and describe each transformation in words. Let's start with our regular one. I can fit all the way to 7 here. So that's my parent. Does anyone have a educated guess that they think that 2 might be doing that's under the square root with the x, but in front of it? Or what it might affect? Yep. Does it go this way?
Yeah.
If it were negative, it would. It's going to affect the overs. You know how when we had a 2 out front, it affects the ups? Or we had a 1/2 out front, it affects the ups. So to have it multiplying by underneath the square root is going to affect the overs. Okay? Now it looks like we're going to double the overs. But anything that has to do with the x is always the opposite of what you think. So in fact, we're going to half the overs. But I want to show you on Desmos so that you believe me. Okay? So square root of 2x. So normally we would go on our regular one, which is red, over 1, which is here, up 1. Okay? But instead, we're going to go over 1/2, which is here, up 1. Okay? Our next over, what's our next over generally for the square root function? After we go over 1, up 1, we go over 1, 2, 3, up 1. Do you agree? So what's half of over 3? 1.5, so we're going to go over 1.5. So we went over 1/2 up 1. Now we're going to go over 1.5 up 1. Okay? Oh, I can actually do this. Okay, so do this. Over 1, I know the scale's weird, up 1. Everybody good there? Over, so see the scale? I don't know how to change it. Over 1, 2, 3. Sorry, over 1, 2, 3, up 1. Okay? Over 1, 2, 3, 4, 5, up 1. Okay? So instead we're going to go over 1/2, which is 1 square, up 1. Over 1.5, which is going to be 3 squares, up 1. Over, what's half of 5? 2.5. 1, 2.5, up 1. And then I can keep going over 7. What's half of 7? 3.5. So over 1, 2, 3.5, up 1. Okay? So my overs are going to get cut in half. All right, so let's try it for real. All right. So now we're on a scale of 1s, which is easier. Over 1/2, up 1 is going to be halfway there. Okay? The next over for the square root function is normally over 3, but I have to half that over. So half of 3 is 1.5. So I'm going to go over 1.5, which puts me on a corner, but my up is still 1. Okay? My third over is normally 5. Okay? So half of 5 is 2.5. So now I'm going to go over 2.5 up 1. And you should start seeing a pattern. Over 1/2 up 1, over 1.5 up 1, over 2.5 up 1, over 3.5 up 1, over 4.5 up 1, until you run out of room. Okay? So 1, 2, 3.5 puts me on a corner again, up 1. Over 1, 2, 3, 4.5, up 1. Still got room, so over 5.5. 1, 2, 3, 4, 5.5, up 1, and then I've run out of room. So then join them with a smooth curve starting from 0, 0. You'll have drawn y equals the square root of 2x. Okay? So again, over 1/2 up 1, over 1.5 up 1, over 2.5 up 1, over 3.5 up 1. That's how we got our points. And then when we join it, it looks like that. Okay? This is called a horizontal because we halve the overs. So it's a horizontal compression by a factor of 1/2. So I always say when it's happening with the x is the opposite of what you think. Okay, so it looks like we should be doubling the overs, we're really halving the overs. It looked like we should be going right, we were going left. Okay? X's are always opposite. All right, so based on that, what do you think y equals square root of 3x is going to look like?
Over 1/3 of 1.
Yes. Okay. We're going to go over 1/3 of 1. So 1/3 is maybe here. Okay. Normally our next over is 3. Okay. So if I cut 3 by 1/3, I would only be going over 1. Okay. So you can try that. 3 divided by 3, all you have to do is divide by 3 to get your overs. Okay, so 1 divided by 3 is 1/3. 3 divided by 3 is 1. So from here, I'm going to go over 1, up 1. So I'm going to be like 1/3 of the way into this square. My next regular over would be 5. What's 5 divided by 3? If you write that as a mixed number,
1.66.
it is, okay, 1.6667, but if you write this as a mixed fraction, 3 goes into 5 once with 2 left over, so 1 2/3. Okay, so from here, which is 1/3 of the way into that square, I'm going to go over 1 2/3, which puts me on a corner, and up 1. Okay, my next over is 7. So 7/3. How many times does 3 go into 7? Twice, with 1 left over, 2 1/3. So I'm going to go over 1 2 1/3, up 1. 1/3 of the way into that square. 9/3 is 3. So I'm going to go over 1 2 3, up 1. So 1/3 of the way into that square. 11/3. How many times does 3 go into 11? 3 6 9 3 with 2/3 left over. So I'm only 1/3 of the way into that square, so I'm going to go 1 2 3 and 2/3 puts me on a corner. 13/3. 3 6 9 12 goes in 4 times with 1/3 left over. So from that corner, I'm going to go over 1 2 3 4 and 1/3. Up 1, and then I run out of room to go over, so I'm just going to join it. Starting at 0 0. So that's a horizontal compression by a factor of 1/3. So I divided all my overs by 3. Okay, I divided all my regular overs by 3. And got new overs. And I count my ups the same. 1. Okay, y equals the square root of 1/2 x. So it looks like I'd be halving the over, but what do you think I'm actually going to be doing to the overs? Doubling them. Yes, I'm going to be doubling my overs. So it looks like I should be halving them, I'm actually doubling them. So this one is going to be, what color have I not used yet? Green. This is a vertical stretch. Oh, sorry, horizontal stretch. I got it. Horizontal stretch. Horizontal stretch. by a factor of 2. So I'm going to double my original overs. Okay? Overs are going to get doubled. Double the overs. Okay? So the horizontal stretch does double the overs. So normally, once I started 0, 0, I would go over 1 up 1. Now I'm going to double the over, so I'm going to go over 2 up 1. And then normally my next step I'd go over 3. So now I'm going to go over 6 instead, because 3 doubled is 6. 1, 2, 3, 4, 5, 6 up 1. Then my next over would be 5, but I'm going to double it, so I'm going to go over 10. Up 1. And then I've run out of room. Okay? So this is my horizontal stretch by factor 2. Okay? And then what do you think about y equals square root of negative x? Facing the other way. So this one is a horizontal reflection. So the negative's under the square root sign with the x. Instead of pointing to the right, it's going to point to the left. Okay, but everything else is going to stay the same. So I'm going to still start at 0, 0. And instead of going to the right one, I'm going to go to the left one. And up 1. And then go over 3 the other way, up 1. 5 up 1. 7 up 1. And then you run it. So that's a horizontal reflection. Points in the other direction. Instead of pointing right, points left. Okay, what about y equals negative 1/3 x? There's 2 different things that are going to happen there. Does anyone think they know one of the things that's going to happen? Yep. Horizontal reflection. Perfect. So the negative sign under the square root with the x means it's going to point that way. And what's the 1/3 going to do under the square root sign of the x?
Horizontal stretch by factor of 3.
Yes. So I'm going to triple the overs. Horizontal stretch by a factor of 3. So I'm going to point this way, and all my overs are going to get tripled. Okay? All right, so let's see what that looks like. We're still going to start in the exact same spot. But instead of going over 1, I'm going to go over 3. And I'm tripling my over. Still S1. My next over would normally be 3, but I'm going to triple it. So I'm going to go over 9. Up 1. My next one will be over 5, but I don't have room for over 15, so I've only got room for those 3 points. And then I'm going to join them best I can. So that would be my curve, my image. You can see it had 2 different things happening. A horizontal reflection, the negative sign, and a horizontal stretch by a factor of 3. My overs were tripled. Okay? All right, so given a function y equals f at x, how would you describe the transformation y equals f at bx? So if there's a number in front of x, underneath the square root sign, or in the absolute value bars, or in the brackets of a parabola, what does that number out in front of x do? What if b is greater than 1? So it's a number like 2, 3, or 4.
Horizontal compression.
It's a horizontal compression by a factor of, so think about this, 1 over b. So if b happens to be, if b is greater than 1, it's going to be a number like 2 or 3 or 4. So your horizontal compression is going to be like a half or a third or a quarter. Okay? 1 over b. What if b is between 0 and 1? So that's numbers like a half or a third. B is between 0 and 1, so b is like a half number.
There is no horizontal stretch.
Yes, it's a horizontal stretch. By, so your horizontal stretch isn't by a half or a third, it's by 2 or 3, right? So by, if I say by the reciprocal, meaning flip, right? Of b. Okay? So if b is a half, you're stretching by 2. If b is a third, you're stretching by 3. B is a quarter, you're stretching by 4. Okay? And then what happens if b has a negative in front of it? If b has a negative out front, then what? Yeah. Yes. Then it is a horizontal reflection. Perfect. All right, so now we have some horizontal ones to try here. Sketch the parent function y equals square root of x. I'll be good at that. Okay, so I've got everybody drawing that one by memory now, which is awesome. Okay, so now we want to draw this image, but I always like to do the words first. Okay, so I'm looking at this. Now I see my square root sign. I like to use 2 different colors of highlighters to separate vertical transformations and horizontal ones. It helps me. Okay? So the last ones we always did vertical ones. Horizontal ones happen under or with the x, so under the square root sign with the x. So this is a horizontal transformation, and so is this. They're both under the square root sign with the x, which makes them horizontal. Okay? So that color coding can really help you when there's vertical ones going on and horizontal ones going on. Okay, I was using yellow highlighter for vertical and green highlighter for horizontal. Okay? So then I want to list out what these 2 transformations do. What does that 2 do? It's horizontal, so we know we can start, it's a horizontal something. Horizontal compression by a factor of 1/2. And what about the +3? Horizontal. Darius?
We start on the x-axis, so we'd be starting on the left side of the.
Okay, so we call that a horizontal shift. And it's to the left And it tells you where to start, which is good. So you always look for shifts when you're deciding where you want to start something. You start your function. Okay? So we're looking to see a shift here. So I know I'm going to start 3 left of where my parent function starts. Okay? So I see that shift there, left 3. I'm starting 3 left of where my parent starts. Now I've got to apply the horizontal compression by a factor of a half, which means my overs are getting cut in half. If you need a calculator, just divide your overs by 2. Okay? So normally I would go over 1 up 1, so I'm going to go over half up 1, which puts me right in the middle there. So over 1/2 up 1. And then normally my next over is over 3. So I'm going to half 3. Half of 3 is 1.5. Everyone good with that? So from here I'm going to go over 1.5. So 1.5 puts me on a corner. Up 1. My ups aren't affected. Okay. My next over would normally be 5. So 5 divided by 2 is 2.5. So I'm going to go over 2.5. 1, 2.5, up 1. And if I don't notice the pattern, I have to know that my next over would be 7. 7 divided by 2 is 3.5. So I'm going to go over 1, 2, 3.5, up 1. Then over 4.5 if it fits. 1, 2, 3, 4.5, up 1. So you always want to finish until you run out of room. And then draw in your curve. Okay? And then you want to see do your words match. Is there a horizontal shift left 3? Horizontal compression by a factor of a half is harder to see, but basically what it means is you're taking the original and you're smushing it. So if you smush it in, it ends up buckling up, right? And then you can check. Are my overs half what they were originally? Yes. So I'm good. Okay? And then we want to do the domain and range of our image. I didn't even think about the domain for this one. Jack?
Every real number as long as x is greater than or equal to.
Yes, good. Every real number as long as x is greater than or equal to -3. And how about the range? Jack?
Every real number as long as y is greater than or equal to.
Good. Yes. Perfect. Okay. Awesome. All right. Sketch the graph of the image function y equals 2 absolute value of x minus 3 minus 4. Okay. So this is how I do it. You may not need to do all my steps, but this is how I do it. First thing I would look for is where's the clue in the function to tell me what the parent function is. So how do I know what this is based off of, in other words? What's my parent? Anyone have a, you think they know? Yeah, Jeff? It's the absolute value function, and that's because those absolute value bars are there. Okay? So look for the clue in the question that tells you what your parent function is. And then I always like to draw out my parent function. And another tip I got from Gavin last year was he always did his parent function in the color because he could always do that one perfectly, and then use pencil for the image in case he had to erase later. Okay, and I thought that was a brilliant idea, so I would do that as well. Okay, so always do your parent in a color because you're going to do that one perfectly, and then your image that you might have to erase, do that one in pencil. Unless you have erasable pencil crayons, and then some people do. So I started doing that in my solutions. I used to have to start all over again if I realized, oh, I did that wrong. And then it helps me too. So there's my parent function. I'll label it, because it didn't ask me to draw it, but I always like to draw it because I always like to compare my words, my answer, to the original, which is always the parent. This is where it all comes together. This is an exciting question. Okay, so then I get my two colors of highlighter out. And yellow highlighter is vertical. Okay, your two colors might be different, but for me, yellow highlighter is vertical. So vertical is not in the absolute value bars, it's outside of the absolute value bars. So this is vertical, and that's vertical, because they're both outside of the absolute value bars. And then I get my other color of highlighter out, green, and the only thing inside the absolute value bars of x is the -3. Okay? So I know when I'm listing out the transformations, which is part C, I'm going to list out vertical when I'm talking about the 2, vertical when I'm talking about the -4, but horizontal when I'm talking about the -3. Okay? So, does anyone think they know what the 2, the yellow 2 is going to be? Yes?
That's our up,
Yes? What do we call it? That would be if it was a half.
vertical stripe.
Yes. So remember, the other thing that's good to know is verticals are what they look like. Horizontals are the opposite of what they look like. Okay? So vertical stretch by a factor of 2. So our ups are being doubled. What about the -3? It's in green. So I'm going to start off with horizontal first. Horizontal what? X -3. Who thinks they know what that means? Yep. Yep, horizontal shift. Good. Horizontal shift. And is -3 to the right or to the left? Right. Right 3. And then the -4 on the outside of the brackets, it's got to start with the word vertical, because it's not in the absolute value bars. Vertical shift. Good. Down 4. Not by factor 4, just down 4. Use by a factor if you're talking about a stretch or a compression. Okay? Just use just a number. Okay. Love this. Okay, so now I've got a vertex for an absolute value function, so I want to move it, so I'm looking for shifts. Okay, and I've got 2 shifts this time. So I'm going to shift my vertex, right 3, and down 4. So there's where my new starting point is, or my new vertex is. So I've done my shift to the right, and my shift down 4. Okay? Now I just have to apply my vertical stretch when I start drawing the other points. So my overs are still going to be the same, they're not affected, okay, but my ups are going to double. So instead of going up 1, I'm going to go up 2. So over 1, up 2, over 1, up 2, over 1, up 2, and you just keep doing that until you run out of room. For absolute value, make sure you use a ruler. Arrows on the ends, and then always reflect back and see if when you compare it to the original, are we shifted to the right 3? Yes. Down 4? Yes. Are we stretched vertically by a factor of 2? Yes. So we know that our graph makes sense. Okay, and it also has to have the overall appearance of an absolute value function. Okay? And then we also need domain and range for our image. Joanne, did you get all real numbers? Okay, what did you get for the range?
Y is an element of all real numbers.
Yep.
And y is greater than or equal to -4.
Perfect. Okay? Is the idea of what we're doing here? So we're taking the parent and then we're drawing the image. Okay? All right, and then the purpose of our transformations here, so I'm going to color code. A is out front, K is at the end. So my vertical, so my horizontal. And then I'm just going to kind of do an arrow here. So A is either a vertical stretch or compression. So if it's out in front, it's either a vertical stretch or compression. And I'm going to do the K next too, because it's vertical. So if it's at the end, way at the end, not inside the absolute value bars or under the square root sign, it's a vertical shift. Up or down. If it is under the square root sign or inside the absolute value bars, B is a horizontal stretch or compression, depending on its value. And H is a horizontal shift, left or right. So inside with the X, horizontal, out in front, or way at the end, vertical. Okay? And then the only things to remember are, if A is negative, you have a vertical reflection. So that's points down. And if B is negative, you have a horizontal reflection. So points left. Okay, so time to practice some of these. Those solutions, I should stop the recording.